making repairs during a spacewalk before actually taking one. They quickly learn the layout of things and simulate attaching and removing objects on the outside.
I think on a mission to Mars that can take anywhere between 2 and 3 or 4 years to accomplish the mission. All your training would be done on the ground, possibly 2 or 3 years before you ever needed it. So what the virtual reality or the onboard training would allow you to do would be refresh yourself to what you'd learned a couple of years before you did it.
It is inevitable that repairs would need to be made during a mission to Mars. Equipment failures are just one of the many hazards of the mission. Another is cosmic radiation. Because totally shielding a spacecraft would make it too heavy, the crew would get about half the dose that an airline pilot gets over an entire career. Micrometeorites in space whirl around at speeds greater than 30,000 miles an hour. A strike by one smaller than a pencil eraser could cause disaster. And most ominous would be the powerful solar flares that send deadly ions throughout the solar system without warning. On Earth, the atmosphere stops most cosmic rays from reaching the surface, and all but the largest meteors burn up. Even the deadly ions from solar flares are deflected by the Earth's magnetic field. For travelers out of Earth orbit, there would be no protection. But as the Russian space station Mir revealed, the greatest risk to the crew on the long voyage to Mars may be weightlessness. Our bones and muscles are only as strong as they need to be. In space, with no gravity to tug on the human body, bones lose calcium and muscles lose strength. In 1995, the United States began sending astronauts to the Mir to see how the Russians managed to stay in space for a year or more. Astronaut Shannon Lucid broke the American record, 6 months. Astronaut Norman Thagard spent 4 months on Mir, with the Russians a likely partner on the mission to Mars. Thagard collected detailed information on his body's reaction to zero gravity, but mostly he tested Russian techniques for counteracting the effects of weightlessness.
The Russians have a lot of experience in long-duration spaceflight, and they realize that if you don't exercise diligently when you're on these long-duration missions, then you won't be in good shape when you return. Toward that end, the Russians schedule 2 one-hour exercise sessions a day.
The goal of these exercises is to subject bones and muscles to the same forces and stresses they would get on Earth, so that they can remain tuned for Earth's gravity.
Knowing as I did, because I am a medical doctor, that I would quickly get out of shape if I didn't exercise, I was extremely diligent in exercise for the whole while I was on the Mir station.
When Thagard returned, everyone was eager to see if his exercising had paid off.
When we landed, within 10 minutes of wheel stop, I stood up. Wasn't the easiest thing I ever did, but I did stand up, and I remained standing until they opened the doors and got everybody out ahead of me, and then I walked off the vehicle unassisted.
But many cosmonauts have trouble making themselves exercise, like Vladimir Titov, who spent 13 months on the Mir.
Unfortunately for me, it's very unpleasant to exercise when I don't want to. If you like exercising and only have to do it 3 times a week, that's fine. But when you have to do it twice a day, every day for a year, It becomes a boring, hellish task.
Even if cosmonauts follow their exercise routine, some can't cope with gravity after 6 months or more in space.
The issue of what sort of shape folks need to be in when they get to Mars is probably a bigger one than it is for low Earth orbit, in the sense that in low Earth orbit, all you have to do is come back, and if need be, they can carry you off the vehicle. But when a crew is going to Mars and they arrive, they need to be in good enough shape to do real work.
Rotating a spaceship to produce artificial gravity has long been considered the ideal solution to the exercise problem. The principle behind artificial gravity is a familiar experience. When a roller coaster goes around a loop, it creates centrifugal force, which presses it into the track. A rotating spaceship would also produce centrifugal force, pinning astronauts to the spaceship floor, simulating gravity. As an engineering student at Stanford University, John Wilson tested one of the most promising and economical ideas for creating artificial gravity. Using 2 air-powered hover machines tethered together, Wilson showed they could rotate around a center point, as would a spacecraft. Tiny thrusters around each machine fire at just the right time to keep the system stable. The concept proved successful, but it would be a lot more complicated in space.
Whereas this experiment is only about 5 feet in diameter, in space we'd have something that was very large, perhaps as large as half a mile in diameter.
It's unclear how long it would take to build and test a spacecraft based on artificial gravity. So scientists at the NASA Ames Research Center are now investigating another way to produce it. Here, in a chamber that's small enough to be launched in the space shuttle, they've built a bicycle centrifuge, a new exercise machine that harnesses the pedaling power of 2 people to spin one of them around at high speed.
Ready.
The astronauts get a good aerobic workout, and by taking turns on the centrifuge, they also get a strong dose of artificial gravity. Even if the person rotating gets dizzy and stops pedaling, centrifugal force would continue creating pressure towards his feet, giving his bones and muscles the stress they need to stay in shape. The most promising technology for counteracting the harmful effects of weightlessness was recently tested by NASA in a bed rest study. First, volunteers laid in bed with their heads tilted down, a position that caused the same problems astronauts get from zero gravity.
You do, have a little lower back pain, get a headache usually. I think maybe my head's a little fuzzy sometimes too from being in this position, so it's kind of difficult.
Fluids move up to my head, I started getting puffy and my nose starts getting congested. And
your muscles start to atrophy, and that continues, and then eventually you'll start losing bone.
These tests are obviously no picnic for the people who do them.
what's the surprise?
It tastes good at first, but getting it down past your throat gets more difficult.
The object of all the inconvenience was to test a new, improved treadmill for use in space. The problem with current treadmills is that they rely on elastic straps to produce force, and elastics pull harder the farther you stretch them. If the elastic is strong enough for an astronaut to feel his normal weight when he gets on the treadmill, then the elastic will be too tight for him to lift his body up and run. So to be usable, space treadmills can only have weak elastics that produce moderate force, which limits their ability to maintain bones and muscles. The new machine uses a vacuum pump to pull the runner into the treadmill, allowing much higher forces. To simulate a workout in space, Brent Walker had to run lying down so the Earth's gravity wouldn't be a factor.
Brent, we're putting up the treadmill now.
Okay. So if you can pick yourself up, you need to slide down under.
Okay, vacuum's on. Okay, I'm bringing it up to full body weight.
As the vacuum sucked air out of the chamber, Brent's feet were pulled into the treadmill. Lying sideways, yet feeling like he was standing upright and bearing his normal weight, was an odd sensation.
You do get used to it, and sometimes it feels like you're almost flying effortlessly. It's a very strange feeling. You do sweat, though.
Because the machine is experimental, Brent was asked to rate his stress.
Exertion? It's a 13. 13? Okay. Heart rate's 170.
Feeling your normal weight while exercising in space would be double what astronauts get from elastic straps. But the treadmill can also make you feel much heavier.
Okay, Brent, I'm bringing the pressure up to 1.2 body weight.
The harder the vacuum pulls, the more stress on Brent's bones and muscles.
Well, it feels like I have a backpack on, about 30 pounds, something like that. It's just a lot heavier. Definitely just stress in my lungs and my muscles a lot more. It's hard.
The question is, will 40 minutes a day on this vacuum treadmill prevent bone and muscle loss during this study?
I feel my muscles are a lot stronger. They've actually, since I came into it, they've gotten a lot stronger. So I would imagine that it will help me. I mean, it's really difficult to, from my point of view, to know until I actually stand up.
After 2 weeks in the bed rest study, the moment of truth arrived.
Your mark, get set, go.
Brent actually ran faster than before he got into bed.
On your mark, get set, go.
But those who didn't use the treadmill during the study, like Bill Davis, were much slower than before.
I think it's just a feeling of sort of weakness, of not having a lot of energy or a lot of strength.
Okay, make sure your heel is resting here. Okay, now let's start. Okay, push, 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 push. Okay, relax. Okay, another one, push, push, push. Okay, relax. Okay, push, 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 push. Relax. Okay, now push, push.
But those like Brent who did exercise stayed the same or got stronger. Clear evidence that the vacuum treadmill works. Bone loss was assessed by a machine which uses vibrations against the leg to determine bone stiffness.
Feel the weight. Is it uncomfortable?
Just a little bit, but it won't be a problem.
While the results were much less clear-cut than they were from muscles, they do seem to indicate the vacuum treadmill would help astronauts headed to Mars.
If this is any indication, they would be much better off than they would be without it. So this is definitely a good step in keeping people fit in space.
This is Mars Explorer 1, 10-4.
It would take about 102 days for a Mars mission to reach the halfway point on a journey to the Red Planet. Each morning would begin with a routine 1-hour exercise session, including the vacuum treadmill. Astronauts would know the importance of being in good shape when they get to Mars, where they would have to deal with gravity again. The crew would use regular exercise to relieve their boredom during this part of the mission.
I'll be up front. All right, I'll come and get you if I need you.
But there could also be times when no one would think about exercise. On board, alarms might warn that invisible but deadly ions from a solar flare have penetrated the spacecraft. Every second of exposure can increase damage to the body, so the crew would quickly retreat to the only shielded area. Barely 5 feet square, the emergency shelter would maintain a supply of food and allow control over the most vital systems on the spacecraft. The solar flares could last for a few hours or a week or even longer. Travel in deep space is inherently dangerous and unpredictable.